Hello everyone, welcome to our channel of campus. In this video we are going to see short questions and answers in microprocessor. This is a part 2 video. If you haven't seen part 1 video still, kindly check with the playlist. Previously in part 1 we have posted 1 to 10 questions. In this video we will discuss about question number 11 to 20. Okay, 11. What are tri-state devices and why they are essential in a bus oriented system? Actually, what are a tri-state logic device? Tri-state logic devices have 3 states: 0, logic 0, logic 1 and high impedance state. Okay, we know what is logic 0 and 1. Then what is high impedance state? We will see. When the enable, see, this is the tri-state buffer symbol where A is the input. Buffer means whatever given in the input, output follows the input. Okay, whatever given in the input, the output will be same as the input. So when the enable, okay, this enable is given as B, here input as A. We will see, maybe active high or active low. It can be active high or active low, this enable line. Okay, when the enable line is activated, the device works. Whenever the enable line, it may be active high or it can be active low, means here that bubble symbol will come. Okay, whenever enable symbol, it may be active high or active low. When the enable signal is line is activated, then only the device start works. Okay, the disabled enable line makes the device at high impedance state. Okay, that means disabled enable line makes the device at high impedance state. And what is a high impedance state means? It is disconnected from the circuit. Can you understand, guys? It is getting disconnected from the circuit. So we'll see truth table. So input, this is a buffer symbol, tri-state buffer symbol. We'll see, if it is A is 0 and enable is logic 0, means whenever enable line should be active, that active may be high or low. Here when the enable line is active, whenever it is given as logic 1, the enable line is active. If it is given with the bubble, means active low symbol makes the enable line to be activated. Okay, can you understand now? B, logic 0 is here 0 0 means A is also 0, B is also 0. Enable line should be activated. Here active low will what happen? It get disconnected from the circuit. That means it goes to the high impedance state. Okay, next logic level is 0 1. 1 means what? Enable line getting activated. Whenever enable line activated, the buffer starts working, the device start works. Okay, here enable line activated. Then what is the output? This is a buffer, as I said earlier. Output will be same as the input. Output follows the input. So input is 0, so output will be also logic 0. Okay, then what is the next state? 1 0. Input is 1, enable line is 0, means it goes to automatically, enable line is not getting activated, so it goes to the high impedance state. That means it is disconnected from the circuit, so it is output will be high impedance state. Okay, then next logic level 1 and 1, both are 1, means enable line is 1, so the device starts working. Input also given as 1, so what is the output? Output just follows the input, whatever input given, that will follow the output, so output will be 1. Okay, can you understand, guys? This is the tri-state logic devices and its working. We'll move on to the question number 12. Why program counter and stack pointer are 16-bit registers? Why PC? In short, we can call it as PC and SP. Okay, we'll see. Because SP points to the beginning of the stack memory. It always points to the top of the memory location. Whatever it is, an example LXASP 8000H, which is 16 bits. Memory related to what? Address bus. Address bus is 16 bits. So stack pointer register is usually 16 bit. Let's see the what is program counter. Also program counter, what is the working of program counter? Points to the address of the memory location, next address of the locations of the instructions to be executed to maintain the proper sequence of execution of program. Actually PC points to the address of the next instruction to be executed. So that is also related to address bus. So address bus is here 16 bit. So program counter also 16 bit register and stack pointer also 16 bit register. So the question is why are PC and the SP are 16 bit register? We have an answer. Okay, we'll see. Question number 13. What are the different addressing modes in 8085? So what are the different addressing mode? 8085 usually has 5 different addressing modes. They are register, register indirect, direct, immediate and implicit. We'll see one by one. So what is a register addressing mode means? Data is provided through the registers only. Okay, data is provided through the registers, or operand is only register. Operand means we will see this is in here. Move is a opcode. The next to the opcode is called as operand. RD, RS is operand. So operand is only register. Data is provided to the registers only. So RD, RS means this is source register. This is destination register RD. Okay, data is provided through the register only. So this is called register addressing mode. So move A comma B. For example, move A comma B means just copy the contents of the source register B to the register A. Okay. Then register indirect addressing. What is register indirect addressing? Operand M or register pair. Here operand is M or register pair means this BC, DE, X means X denotes the register pair. LDAX means load data what BC register. Okay, store data DE, D means DE, or given any memory location. Move A comma M or LDAX B means X given means it denotes the register pair. So operand is for register indirect. There is no register is given directly like this one, source and destination register. It is given as memory location or register pair LDAX like. Okay, then coming to the direct addressing mode. What is direct addressing mode? Operand 8-bit port address or memory address. Okay, 8-bit port address or memory address given. Operand means this one. What will be the operand? 8-bit port address or a 16-bit memory address. It may be 8-bit port address or 16-bit memory address. Okay, it is given as a direct addressing mode. In 84H, out 84H, all call instruction come under direct addressing mode. Then immediate addressing mode. Instruction having the letter I. Okay, instruction having the letter I. See MVI or immediate data to the destination provided. Immediate data provided. So MVI what data will be provided? MVI M comma 2H means this 2H data will copy the content of data. Copy this data to the given memory location. Also all jump instructions as the meaning is jump immediately. Okay, this is the examples for the immediate addressing, which is nothing but letter I or immediate data to the destination is provided in the operand itself. Okay, then implicit addressing mode means no operand. Here see no operand. So this is XCHG comma CME. XCHG means exchanges the contents of the memory location with DC and BC and DE pair register. Okay, BC and DE pair register. This is CME is nothing but complement the accumulator. Complement the contents of the accumulator. Whatever content in the accumulator, we just going to complement. Okay, there is no operand in the implicit addressing mode. So these are all the different addressing modes in the 8085. Okay, we'll go to the next one. What is the difference between move and MVI? So both MOV means move and MVI instructions copy the data between two registers. The process is nothing but same for move and MVI means just copy the data between two registers. Okay, whereas move instruction copies the data between two registers. Move register means here example, see move A comma B means just copy the contents of the register B to the contents of the register A. Whereas for MVI instruction transfers an immediate data into a register. So MVIA, 47H is nothing but this is a 8-bit data. So this 47 data will move to the transfers that data to be transferred to the memory given accumulator. Okay, here immediate data is given, here copies the data between two registers. Okay, this is the difference between move and MVI. Then what happens during DMA? What is actually DMA transfer? What is actually DMA? Direct memory access. It is usually used to speed up the process, speed up the data transfer without the without using the microprocessor unit, directly access the memory location. Okay, we'll see now what happens here. Two signals are very important here, hold and HLDA. Hold means hold signal, HLDA means hold acknowledgement. After receiving the hold signal will get a acknowledgement, no? So hold acknowledgement signal, HLDA. We'll see. To make a fast data transfer, the MPU is nothing but microprocessor unit releases the control of its buses to DMA. Okay, to make a fast data transfer, the MPU releases the control. It will release the control of the buses to DMA. That is a direct memory access. So without the accessing the MPU, we are going to access the transfer between address location. For what purpose? To speed up the operation. So DMA act as an external device and the active high input signal hold goes high when the DMA is requesting to the MPU to use its bus. So when the DMA is requesting to the MPU to use its buses, the active signal, this whole signal goes high. After receiving the hold request from DMA, the MPU, what will happen? Releases the buses in the following mission cycle and generates an active high output signal, HLDA. This is a hold is active input signal. After receiving that control the high output signal HLDA, indicating the release of buses. Once the DMA gains that control, it acts the role of the MPU. So once it gains the control means what will happen? It acts the role of the MPU for data transfer. So this is the process of DMA transfer. Then what is PSW? Actually, what is PSW? PSW is nothing but program status word, represents the contents of the accumulator and flag register together considering. Okay, program status word combinedly denotes or specifies the accumulator and flag register. Okay, program status word represents the contents of the accumulator and flag register together considering the, here accumulator is a higher order and flag is the lower. This is very important, whereas accumulator is the higher order and flag as the lower order register, as if it is the AF means accumulator flag register pair. For example, POP PSW. Then question number 17. What is actually ALE? What is ALE? Explain the functions of ALE. So actually what is ALE? ALE means address latch enable. Okay, it is the acronym for the address latch enable. Acronym for ALE means address latch enable. It is the pin number 30. Pin number 30 used to demultiplex the multiplexed lower order address or data bus. It is used to demux the multiplexed lower order address or data bus. What is actually ALE? What is used? In the name itself, it is used to enable the address latch. Okay, it indicates whether the bus functions as address or data bus. Okay, it indicates whether the bus functions as address bus or data bus. Previously we have explained in part 1 video what is bus and address bus and data bus and control bus and all that. If you haven't seen that video, still kindly check with the playlist. Okay, we'll come to here. If ALE is 1 means bus function as address bus. If ALU is 0 means then bus functions as a data bus. Okay. It is a pin number 30, address latch enable. ALE means it is used to demultiplex the multiplexed lower order address or data bus. If ALE is 1 means bus functions as address bus. ALE equal to 0 means bus functions as data bus. Then question number 18. Which line will be activated when an output device requires attention from CPU? Which line will be activated when an output device requires attention from CPU? Which line? Interrupt request. That means INTR. INTR means interrupt request will be activated when an output device requires attention from CPU. It is a pin number 10 and it is an input signal to microprocessor. It is an input signal to microprocessor. It goes high when external device want to communicate. Whenever external device want to communicate, that INTR signal goes to high. It is a pin number 10 and input signal to microprocessor. Okay. Then question number 19. Can an RC circuit be used as a clock source for 8085? Usually LC or crystal oscillator circuit can be used as clock source for 8085. At times, yes, it can be used. RC circuit also used if an accurate clock frequency not required. Whenever accurate clock frequency is not required, we can use the RC circuit because the component cost is low when compared to the LC or crystal. Okay. Then which interrupt is not level sensitive in 8085? So we will see which interrupt is not level sensitive means RST 7.5 is a raising edge triggering interrupt. Okay. RST 7.5 is a raising edge triggering input. So it is not level sensitive, it is a raising edge triggered interrupt. It is not a level sensitive, it is a edge triggered input. What? RST 7.5. Okay. In this video we have seen around 10 questions from question number 11 to 20. We plan to post part by part in microprocessor. Thanks for watching. If you like this video, kindly share and subscribe.